In this video, I want to talk about square roots and nth roots. So hopefully a lot of this will be review. Maybe you've seen this in high school or in previous math classes. There's a few basic rules we need to go over just to make sure we're familiar with square roots and nth roots. Okay, so a square root, just put simply, is if you have some number, you're taking the square root of it, you're trying to find what number multiplied by itself would give you that number. Okay, so just as a really quick example here, let me move all this down. Okay, for a really quick example, if we have the square root of 4, hopefully we know that that is 2. Okay, and what this is saying is that 2 times 2, or 2 squared, is equal to 4. So you can kind of think of a square root as undoing a square root. Okay, or if you have something like the cube root of 8, or the third root, so to speak, of 8. Okay, this is also 2. Okay, and this is kind of the same thing. This is basically saying that 2 times 2 times 2, or 2 to the third, gives us 8. So you can kind of think of a cube root as undoing a cube, right? Or raising something to the third. And it's similar with a fourth root or a fifth root or a sixth root and so on, right? You can do this for any number you wish, right? So, but we do have one quick rule we have to look at here. We're going to let a and b be positive real numbers. Now, that's really important here. A and b both need to be positive, or at least, they need to be both positive. That's very important. Okay, so they can't be negative. Then, if we have the square root of a divided by b, we can also write that as the square root of a divided by the square root of b. And similarly, if we have the square root of a times b, like we have here, then we'll have the square root of a times the square root of b. So let's look at this in practice a little bit. We'll just do a couple of the fraction examples. So we have the square root of 100 over the square root of 9. So we can actually just go ahead and rewrite this, since both a and b, in this case 100 and 9, are positive. So we'll have the square root of 100 divided by the square root of 9. And the square root of 100 is just 10, because 10 squared gives us 100. So we have 10 over the square root of 9, which is 3. Okay? So you can simplify this to 10 over 3. Okay, how about this one? Here we have the square root of 12 over 75. So one thing that I would encourage you to do is try and simplify any fractions that you can before you're able to, before you try to do anything with square roots, because things can get pretty messy if you don't do that, right? Not that you can't solve it, but it's a lot simpler if you can do that. So what we'll notice right away is that 12 and 75 are both divisible by 3. If we divide 12 by 3, we get 12 divided by 3 is going to give us 4. Okay, and then 75 divided by 3 is going to give us 25. So hopefully you can see this is going to go a lot nicer now. We'll then have the square root of 4 divided by the square root of 25, which is going to give us 2 over 5. Okay. Okay, let's remember our rules about signs as well. So if we have the square root of a being, one rule we have here for signs is we have the square root of a as a real number if and only if a is greater than or equal to 0. If a is less than 0, i.e. if a is negative, if you see a negative sign in front of your number, then we have a is not a real number, okay? And this is because you can't multiply two numbers, you cannot multiply a number by a negative number, you cannot multiply a number by itself to give you another negative number, right? So here's what I mean by this. Let me scoot this down. If you have, for example, let's say we have the square root of -4, right? You might be tempted to say -2. Well, the problem is if you have -2 times -2, or -2 squared, the negative signs cancel out. They become positive, and -2 times -2 is going to give us +4. So that couldn't work, right? And obviously, 2 times 2 is also going to give us positive 4. So anytime you square a number, it becomes positive. So if you have the square root of a negative number, we have to say that it's not a real number. And this also goes for any even exponent. Anytime you raise a number to an even power, it's always going to be positive. So if you have the nth root, where n is an even number of some number, and that number is negative, then we have to say that it's not a real number. So let's look here at this one. Here we have the square root of -9. Well, right away, because we see that negative sign, we have to say that this is not a real number. Okay, and one thing that I do want to say about this is it might be tempting to say no solution here. That's actually not true. If we have time later in the class, we may get to complex numbers, but there actually is a whole field of mathematics based around taking the square root of negative numbers, okay? You can do a lot of really, really cool stuff in math if you're allowed to take square roots of negative numbers, but we just say it's not a real number, okay? So I'm not going to be overly picky with that on a test or anything, but I do think it's worth noting that it's not that there's no solution, it's just that it's not a real number, okay? But how about if we have a negative square root of 9? Well, this is totally fine because the negative sign is on the outside, okay? So we'll start by taking the square root of 9, and that's going to give us 3. So we'll have -3 as our answer, okay? The square root of 9 is 3, and we multiply it by a -1. If we want to see this in a little bit slower detail here, we could actually just rewrite this as -1 times the square root of 9, which is -1 times 3, which is -3. Okay, how about the square root of -25? Okay, and I've seen this mistake made before, so I wanted to address it here. You can't cancel out the square roots like this, okay? Or not the negative signs like this. These two negative signs here, they don't cancel out. You just simply can't do anything with a negative square root if you're forcing yourself to stay within the real numbers. So we have to again say not a real number. Okay? And obviously, if we have negative square root of 25, this is the same thing as -1 times the square root of 25. And the square root of 25 is just 5. So we have -1 times 5, which is -5. Okay, so let's take a look at the nth roots here. So we have, let's change this one up. Let's go, that's not 3. Okay, we have several topics on several examples on nth roots. We're going to do a few cube roots to start with. Okay, let's leave it as 8. Sorry, ignore me for a second. So we have nth roots here. Let's start by looking at the cube root of 125. So this is exactly the same concept as square root. So like I said earlier, this is the same thing as finding the number that multiplied by itself 3 times gives you 125. Okay, so there's some memorization to this, but there's also some. The higher this number gets, like 3, 4, 5, but the bigger that number gets, oftentimes the easier it is to just deduce what it's probably going to be. So you start thinking about because these numbers get very big very fast when you take something to the third power, right? So if we take 2 to the third power, that's going to give us 8. If we take 3 to the third power, that's going to give us 27. So it's growing pretty quickly. A good guess for this would probably be 4 or 5. But the answer here is 5, right? So if we take the third power of 125, we get 5. And this is since 5 to the third is equal to 5 times 5 times 5. 5 times 5 is 25. Times 5 is going to give us 125, right? So you can always double check your work that way and take something to the third power. How about this, though? This is the cube root of -125. Okay, I mentioned earlier in this video that if you take the nth root of a number of a negative number and n is even, that's a problem. But when n is odd, in this case 3 is odd, you can actually do that. And the reason is because if you take a negative number to an odd power, the number will remain negative, right? So this is actually going to be -5, okay? And this is because we can take -5, we can raise it to the third power, and that's going to give us -5 times -5 times -5. -5 times -5, that's +25, times -5 again is going to give us -125. So notice since we raised it to an odd power, we have 3 negative signs, therefore we get to keep that last negative sign, right? So we can do negative cube roots, okay? So how about the cube root or the third root of 8? Okay, that's going to be 2, right? Since 2 to the third equals 2 times 2 times 2, which is equal to 4 times 2, which is 8. Okay, and similarly, if we have the cube root of -1000, we can do it just like we did with -125. So the cube root of 1000 is going to be 10, right? So this is going to give us -10, since -10 to the third is equal to -10 times -10 times -10, which is equal to +100 times -10, which is -1000. Okay, so I did want to go over another rule we have here, and this is rewriting nth roots as rational exponents. Okay, that sounds kind of intimidating, but it really isn't that bad, and it actually simplifies your problems quite a bit sometimes. Okay, so let's say we have the square root of x. Okay, the square root of x. We have the square root of x. We can actually rewrite this as x raised to the 1/2. Okay, so what we're doing here when we have a square root, we have this implied 2 here, so we can think of this as the second root of x, so to speak, the 2 root of x, right? So we can rewrite this as x raised to the 1/2. Similarly, if we have x, the cube root or the third root of x, we can write this as x to the 1/3. And if we have the fourth root of x, we can write this as x to the 1/4, and so on, right? That was going to be very helpful for us here in just a minute for these next couple examples, and we'll see why. We'll see why it can be helpful to write it that way. So let's take a look at the cube root of 8 times u to the third. Okay, remember if we have that a and b are both positive, we can separate the two. So we can rewrite this as the cube root of 8 times the cube root of u to the third. Okay, but now let's go ahead and rewrite this. We know that the cube root of 8 is 2. We did that in a previous example right here, okay? So we know the cube root of 8 is 2. So we have 2 times, we're going to have u to the third raised to the 1/3. Now, remember, if we have an exponent raised to another exponent, so if we have a to the b raised to the c, this is just the same thing as a to the b times c. We can multiply the exponents. So we can rewrite this as 2 times u to the 3 times 1/3, and 3 times 1/3 is just 1. So we have 2u to the 1, or just we can rewrite this as 2u. So the third root, or the cube root of 8u to the third is just 2u. Okay, how about the fourth root of 16y to the 16th? Okay, well, we can split these up. So we can write this as the fourth root of 16 times the fourth root of y to the 16. Okay. So the fourth root of 16 is just going to be 2. Okay, since 2 times 2 times 2 times 2 is 16. So 2 to the fourth is 16. So we have 2 here. And then we have the fourth root of y to the 16th. So we can write this as y to the 16th raised to the 1/4. Okay. So we'll have 2 times y to the 16 times 1/4. And 1/4 of 16 is just 4. So we have 2y to the 4th. Okay, so so if you can rewrite this in terms of rational exponents, this actually turns this problem that looks pretty messy into something that's quite a bit more manageable, right? Using our exponent rules. Okay, let's take a look at one more. Here we have the fifth root of 243 w to the 35th. That looks really messy. But maybe you're not familiar with fifth roots, and that's okay. There may be some trial and error here. So we know that 2 to the 5th is going to give us 32. So let's see what happens if we take 3 to the 5th. You can use a calculator for this too, by the way. We'll immediately get 243. Things get very large as you increase the exponents here. So we know that the fifth root of 243 is going to give us 3. So when we rewrite this as the fifth root of 243 times the fifth root of w to the 35, we can rewrite this as 3 times the fifth root of w to the 35. And we can rewrite that as 3 times w to the 35 to the 1 over 5. Okay? Or 3 to the w to the 35 times 1 over 5. And 35 times 1 over 5, or 35 divided by 5, is going to give us 7. So we have 3w to the 7th.